Yes. All right, guys. Before we get started, are there questions on the homework? So, 49. Yeah, you had it. It's just applying ln. So we'll look at 49 first. 732. Oh, I don't have to do that. All right, guys. 49 on 6, or not 7. Did I say 7?
Yeah.
6.32. So 49, we're trying to find the inverse. Guys, we're finding the inverse of y equals e to the 3x. Now our first step would have been to rewrite y as f, or f of x as y, but we don't have to. Our next step is to switch x and y. Now we're getting y by itself. Now since there's nothing added to e, and that was kind of a step above what we did, and all the homework problems never hit that point, we get e by itself. Now there's two ways we can go about doing this. One is that we do the switching method, going from exponential to logarithmic with our e. The other way is, well, we apply ln to both sides. Okay. In e to the 3y. We apply the natural log to both sides. And part of the reason we do this is because ln of e, the natural log of e, is 1, because it simplifies out the base and what's inside are the same. But yeah, so really the 3y moves to the front, ln of e is 1, leaving us with just 3y. The other side is the natural log of x. And the last thing we need to do is to get y by itself, telling us y is equal to ln of x over 3. And that's our final answer. So with any of the inverse ones, if we start off with exponentials, variable x is in the exponent. Our inverse, the x should be inside of a logarithm. If the problem starts in logarithmic, x is inside a log, its inverse, the variable x, should be an exponent. They kind of flip. Questions on this here? It's not as bad as it seems. Yeah. So what we did yesterday was our properties of logarithms. And this here is the only other part of the homework that we didn't actually cover yesterday. Now they told us here that log base 2 of 3 is approximately 1.585, and that log base 2 of 7 is approximately 2.807. So they gave us those two values. And they want us to evaluate each one of these logs. Now to do that, we're going to use 3 and 7 to rewrite them so that we get to a statement, or it written with log base 2 of 3 and or log base 2 of 7, one or both. Now if we look at the first one, log base 2 of 3 over 7. Well, this would be our quotient property. Because the quotient property states that if we have two things being divided inside the log, we can rewrite it as subtraction of what's on top minus what's on bottom. Log base b of m over n is equal to log base b of m minus log base b of n. Quotient. Product. Power. Okay. Questions on what we did there? Well, I know the value of log base 2 of 3. It is 1.585. minus log base 2 of 7 is 2.807. Questions on this so far? We good with this here? We can read it from back here. Okay. I did, if you notice, I did figured out how to change the thickness of the stylus, so making sure everybody can read it still. Yes? Well, now we just need to plug it in and subtract. Yes. And that's it. Now, as we look at the next one, log base 2 of 21. Well, they didn't give us that one, but can we rewrite 21 using 3 and 7, either with multiplication, division, or exponents? Well, factors of 21 are 3 and 7, because 3 times, yeah, we can factor it. We're just trying to find either multiplication, either taking the two numbers and multiplying them, dividing them, or saying 3 to a power, 7 to a power to get that number. And 3 times 7 would give us 21. Yes? Now, according to our product property, anytime we have two things being multiplied inside the log, we can rewrite it as addition of the two logs. And in the general form, our product property states that log base b of m times n is equal to log base b of m plus log base b of n. Right. Because our next step is going to be almost the same as the first one, but instead of subtracting, we're adding. It will be positive instead of negative. 1.585 plus 2.807. And at this point here, we just need to plug this in to the calculator. Thank you. 4.392. That's it. And the last one we had is log base 2 of 49. Seven squared, yes? Is our 49. Well, according to our exponent property, we put the 2 in front of it, telling us that we have 2 times log base 2 of 7. And it might be tempting to just say the 2 and log base 2 cancel out. They don't, because we're just saying we have it twice.
Would you times it by the number that it turns into?
Yeah, so we would take log base 2 of 7 as 2.807, and then we'd multiply it by 2. I believe it's 5.614. That's it. I will preface, one of the problems on the homework is not as clear, especially with the division one, because if they'd have picked, say, 6 instead of 7, well, our division 6 over 2 is 3, yeah? So we'd be looking at log base 2 of 3. Well, it's still the division one, we just had to set it up the way it needed to be done. Questions on this here? We'll look at 3 more of these. I worked this a few times yesterday and kept telling myself I need to resize this because it's hard for me to write the problem out and have the information at the top. But if we look at the first one, log base 3 of 4/5. this is the same as what? Log base 3 of 4 minus log base 3 of 5. Well, log base 3 of 4 is 1.626 minus 1.465. At this point here, we would subtract, giving us negative 0.216. And that's it. Questions on this here? We're good. We'll get there. So again, all we're doing is we're taking these properties, and I didn't write the power one out on the whiteboard, and applying them to these here. Now our power property, log base b of m to the n is equal to n times log base b of m. So indeed, so here we rewrite 20 as 5 times 4. Now we're doing that mainly because we do have the values for 5 and 4. Which will tell us that we have log base 3 of 5, bless you, plus log base 3 of 4. Log base 3 of 5 is 1.465. And we're going to add to it our log base 3 of 4, which is 1.262, which add together to give us 2.727.
Yep.
Questions on this one here? Last one. We have log base 3 of what? 5 squared, because 5 squareds are 25. Now, according to our power property, we would move the 2 out front, giving us 2 times log base 3 of 5. So we're doing 2 times our 1.465. 2.93. Yes, thank you. So that's it. We're ready for the last part of this note sheet. Yes? Change of base formula. Because as we noticed with doing these so far, if the base is not 10 for logarithms, or as a natural log with a base of e, we have to use the graphing calculator to calculate it. We go math. So, you're welcome. So if the base was something other than 10, we had to go to the graphing calculator, do math, log base, and type the whole thing in. Now, if we had a way to rewrite it so that the base was 10, it would be nicer because the log button that's on both calculators, we could use it. And that's what this does. And what it says that any logarithm with a base, we can change it to log base b of a over log base b of b. We're changing the base, and for the most part, we're just going to change it to 10. So we can rewrite any logarithm as log of a, what's inside, over log of the base. Or we could say natural log 2. So if we're looking at log base 3 of 8 with this change of base, The top would be log of what's inside, which is 8, over log of the base, which is 3. Which this here would be the same as the natural log of 8 over the natural log of 3, because we can change the base to whatever we want. So if we change the base to e, we don't write log base e, we just write natural log. We can do this in either calculator. Well, at this point, might as well wait for this thing to open. There we go. So we could say log of 8 over log of 3, and we get 1.892789 going on this here. We can say the natural log of 8 over the natural log of 3 is same thing. We'll go out 3, 1.893. Yeah. Question? We like this? I mean, it's not too much to it. How about the next one? What would it be? Log of 11 over log of 7. Because we could say the natural log of 11 over the natural log of 7. And we can plug it into the calculator.
For this classroom.
Yeah. I think they're getting there. Questions on these two here? We're ready for the next two. Well, if it asks to evaluate, because we really should be, but I mean, might as well. Yeah. ln of, not that many ones, over ln of 7 is 1.232. Yep. And that's it. Let's do 2 more. Log base 6 of 24. Log of 24 over log of 6. .774. Last one would be log of 19 over log of 2, which is ln of 19 over ln of 2. Yep. These are just change of base. Homework. Because that's what I think I showed you all the assignments yesterday. Yep. Anybody still copying the numbers down? Yes? Huh? Yeah, I know. Yeah, you're good. Thank you. If it is paused and I don't notice, definitely let me know. We good with writing those down? All right. Well, let's pull that back up. No, don't save changes. 652, we ready for this? I'm just doing this again. We're just doing a few more practice. Because in years past, understanding this, we get it, we go over it once, we feel good. I think it'd be good to just hit this one more time. That's all we're doing. All right? So, log of 7x to the third y. We're going to expand this out so that each log has a single term inside. And with expanding, our order is quotient, product, and then power. So the first one we would want to use is the what? Quotient, yes? Is there anything being divided inside the log? No. So we don't have to use it, we move to product. And if we have a product of two or more things inside the log, we can rewrite it as the addition of each log. So even though there's 3 and our formula states 2, we can still do the same thing. Questions with this here? So we finished product, now we move on to power. And the only one with a power and exponent is the middle. So we move it to the front, telling us that we have log of 7 plus 3 log of x plus log of y. That's it. Questions on this here? The natural log of 6x over y squared. So again, quotient first. So it would be the natural log of the top, 6x, minus the natural log of the bottom, which is y squared. Nice. Then we would move on to product. So our natural log of 6x.
Except where you would do
Our
one.
page doesn't have a square.
Okay, I will remove it.
Anybody else?
Which would just be minus natural log of y. And since there's no square, yep. So ln of 6x, since the sign in front of it's positive, when we split it with the product, they would both stay positive. One other way we can make sure is if it's in the top of that fraction, the sign in front of the natural log is going to be positive. Sign in front of our logarithm is positive. If they're supposed to be in the bottom, the sign in front of it should be negative. Questions on this here? It's the same thing. Let's look at this one. Log of 7x to the third y squared over 3. Seven x to the third y squared minus log of 3. Because the only thing in the bottom of the fraction is log of 3. Now these do sometimes show up on the ACT. Well, how many terms are in the bottom of the fraction? So that means only one term should be minus, yes? Yeah. Nice thing with the ACT is they give you multiple choice. If more than that one has a minus in front of it, those answers are wrong and you can get rid of them. Well, next thing we can do is the product, and this would be log of plus log of y squared. So we got this here, yes? Will there be a number in front of the log of 7? Well, the only way there would be is if there's an exponent attached to 7, yes? Which there's not. So if the ACT gave us a number in front of log of 7, we can remove it. And there's a good chance one of the other answers is going to put the wrong number in front of log of x or log of y or both. But the last thing we need to do is our powers. So it'd still be log of 7 plus 3 log of x. Guys, let's focus in. Plus, if we were condensing, yes. If we were condensing, we would pull that negative back up. But since we're just expanding, we'll leave it alone. Questions on this here? Guys, let's focus back in. We feel good with expanding. Yeah, even though you weren't here yesterday, it's not too bad. Let's look at this one here. I put this one here on purpose. Quotient would be first, yes? Is there any quotient or division at all? No, so we move past it. Product. We'd have ln of 7 plus ln of x to the 4th plus ln of 3 squared. I put another set of parentheses because the outer set is showing what's contained inside the log. The other set is showing that that y minus 3 is being squared. Right, because if that 2 was on the outside of the parentheses, we were saying that the logarithm itself is being squared, not the term. And the big, guys, the big difference between those two is our power property wouldn't hold true if we're squaring the log itself. The power property is being applied to what's inside. So there's a distinction between the two. Now the last thing is our power property. The natural log of 7 would stay the natural log of 7. Our exponent of 4 would move up. So we say we have 4 ln of x plus 2 would move to the front, telling us that we have 2 ln of y minus 3. We don't need the second set of parentheses around it because that exponent of 2, which was what we needed it for, is now out front. Yes? Now it feels like we should be able to do something with y minus 3, yes? And this is where it sometimes gets a little bit, because here we do see the minus and we want to use this here. But where is the minus? Is it inside the log or is it outside? Outside, yes, we're subtracting 2 logs to make it the 1 log being divided, yes? Here the minus is inside the log, yes? Those properties don't connect. That is the answer. If we have addition or subtraction inside the log, none of our properties work with that. All the properties work with multiplication, division, or powers, exponents inside the log, not addition or subtraction. Does that make sense? Yeah. So it's very tempting to try to say that the natural log of y minus 3 is the natural log of y over the natural log of 3. Yeah. Because if you notice, it's probably hard to see at the very top, it says 6.52 AP on the video. So up there, it's very small at the very top. AP, additional practice. We're going to do a few of the condensing. When we condense, so condensing steps are a little bit different. Because normally, as it's quotient, product, power. That's how we do expanding. We remove quotient. Yes. Power, guys, let's focus in. Take the, guys, let's focus in. Take the power. And then the second is product. Now on some, we saw one yesterday where using the quotient rule made it a little bit easier, a little bit simpler. But on a whole, I think these two hold out better. Because the first thing we'll do, guys, is our power. We're going to take our powers. So for the first one, 3 log of 47. Log of 47 almost to the third, just the 3 power. We would say negative. Right, if it was minus in front, then yes, we would say negative 3 power of this here. Now, with our negatives, it seems like we would want to leave them, but if we take this next step, we take the negative up. And if there's not a number written there, it's 1. So we take the negative 1 power up, which changes our sign in the middle from subtraction to plus. Guys. Now, questions on this here. Now we have addition, and if we have 2 things being added, we can rewrite it as a single log with what's inside being multiplied. Now, because it is a number and a variable and not just straight numbers like we had yesterday, we don't necessarily need the multiplication dot. We could just say 47 to the third, y to the negative first. And now it was kind of nice yesterday because at this point, we could just plug the whole thing into the calculator and it did it for us. But here, the variable y, we need that exponent positive. And to make it positive, we move it from the top of the fraction to the bottom. Now the top is going to be 47 to the third. And if you know what that is off the top of your head, I do not. Yes. 103,823. Oh, 3,823. Because if we can simplify the numbers, we're going to. Now, if it's just over y, yes, because that's the only term that went back into the denominator. Now, if the calculator, you plug it in and it gives you e times 10, it turns it into scientific notation, leave it, leave it. There's really much more than 3 for this here. There's 47 to the 5th. Okay, that works, 47 to the 9th. Scientific notation here, leave it as 47 to the 9th. If you're having to actually pull up a different program to get the whole number, leave it in exponential. Yes, yes, yes. Here, so we moved the y to the negative 1, got the power positive. Then I took 47 to the third. I just stuck it in the calculator to see what it was. See what 47 times itself 3 times is, which should be 103,823. If it gave us to us like we saw 47 to the 9th, exponential, it's times 10, just leave it as that power. Does that make sense? So exponential, we'd say log of 6 to the third, minus, or well, plus, because here, log of 5 to the negative 4, plus log of 7 to the third, because we want to take these numbers back up as exponents, and we take the negative with it. And this is one of the cases where I feel this taking the negatives with it makes it helpful, because otherwise we would need to really arrange it so the two positives are first, all the ones with minus are second. Then we would group and group and go from there. Now they all multiply together. So I said we have log of 6 to the third times 5 to the negative fourth times 7 to the third. Now this one here, I'm going to write it back out just so we can kind of see this. The 6 to the third and 7 to the third stay in the numerator because their exponent is positive. The 5 to the negative fourth, since the exponent is negative, we move it from the top of the fraction to the bottom. And doing that, it makes the exponent go from negative to positive. 6 cubed times 7 cubed over 5 to the fourth. Fraction 6 to the third times 7 to the third over 5 to the fourth. 74088. Over 625. Questions on condensing? Do we feel good with these here? Yeah. Questions on any of these here? Well, change of base and our other properties that we had. Well, you can write this down if you want, but I think the numbers are a little off. They are. I need to fix it. If that's wrong. This is yesterday's homework. So, questions on this here? The only thing we have left of chapter 6 is solving. And that's after spring break.